It needs to be heterogeneous. And I think there's no one company, one partner that works for any one of us. We need to sort of work on this together. And that's why I think you're one of our most important strategic partners.
Thank you, Santosh. And look, we completely agree with your philosophy. Now, you are actually one of our broadest partners, because if you think about our work on CPUs, GPUs, we developed the rack scale OCP systems together. Yep. You've deployed lots and lots of CPUs, so millions of CPUs, yep. And you're a lead partner on Venice. Can you just talk a little bit about sort of your CPU infrastructure and some of our work together?
Sure. It's been many years. And the story that Lisa was saying was many years ago. I think we went from Milan to Bergamo to Turin, now to Venice. So it's at least yes. The fourth generation. So long-time partnership, obviously. I actually think the world is changing in the sense that the world is changing. Every year is a new world these days.
It's like every month.
Months, exactly. So what ends up happening now is that it's not just a GPU game anymore. It's CPUs and GPUs. If anything, I think CPUs are becoming at least as important, if not more. You're looking at a world where sort of the workforce, the workload is changing because while you have your workhorses and GPUs, at the end of the day, there's agentic workloads. You have to run your tools, you have to run your systems, and all the code that's being generated still needs to run somewhere, right? So I'm super excited to work on Venice. I think there's a lot to come there. And you have to think again, this is a theme that I'm assuming will go throughout the presentation, that you have to start thinking about CPUs and GPUs as conjoined things. You hand off workloads. Depending on the workload, you employ the right hardware.
Yes, no, absolutely right. And we've gotten a lot of feedback from your technical team. I think that's what I really appreciate about the partnership with Meta. Now, clearly, you're deploying lots of GPUs too, a lot of accelerators, and you're also one of our deepest partners on the accelerator side, starting with MI300, and then we had a very large strategic partnership announced around up to 6 gigawatts, starting with MI450. Yep. And what we're doing is quite unique with Meta. So can you talk a little bit about sort of the evolution and the MI450 plans?
Again, multi-year collaboration. I think we started with MI300. We did a bunch. It had really nice memory capacity. I remember talking to you about that, right? And then there's a bunch of pipelining we did. It was important to sort of deploy that at production scale, sort of get hands-on experience on both sides. 350 is the first time we deployed this on our ranking and recommendation systems. So that's now getting into sort of some good numbers. And 450 is I think I'm super excited about it. We just got some of the racks, and we are going to deploy it across the board because it gives us the opportunity to go and sort of really collaborate. I think the big difference between sort of the 300, 350, and 450 is that we have had engineers sitting in the same room, yes, talking to each other, co-designing, co-creating, like power, cooling. Like I was saying, it's not just a single thing, and we are not shy in feedback. Like
they're not shy, for sure.
But you're very receptive. So this is true partnership, right? This is the point about co-designing and co-creating that I think. And like I was saying, that's a huge sort of deployment coming in. The more we deploy, the earlier we co-design, the better we are.
Yeah, absolutely. Really appreciate the effort together on MI450. Now, I'm going to ask you also about your crystal ball. So you look out into the future and you see, what the next few years really means as you push forward in the AI industry. What are the biggest challenges and really opportunities for us? This is the industry ecosystem here. So what should we be focused on as an industry?
Listen, all of you know about the bottlenecks. You know about the power, the data centers, the silicon. Like all of these, I think, are choke points that I think the industry is sort of waiting on. But those are things I'm pretty confident will sort of work our way through. At the end of the day, I think the demand is immense. People are responding. But the thing that I really want to make sure all of us realize is that we should not think about systems in isolations. Like I was saying, CPUs and GPUs are one conjoined system. You should start thinking about it that way. We really need to co-design things early. See, data centers takes years to build. Okay, like one of my favorite stories is Mark comes to me and says, hey, I want a gigawatt worth of data centers. Well, you should have talked to me 2 years ago. It takes time, right? It's the same with silicon, right? It just takes time. So we need to be starting and sitting down in a room, co-designing today for what we need to deploy in 27 and 28. That, I think, is when we truly unlock sort of powers of the system. The systems are amazing, the specs are amazing, right? But think about how much more you can get out of it if you sit in a room and just co-design it today. And then in 28, we'll be having much better graphs out there.
Fantastic. Santosh, I completely agree with you. I want to say again, thank you. We are so, so happy with the amazing partnership that we have, across the board, and most importantly, with your engineering teams. And we truly are excited about what we're going to do in the future. Thank you so much.
Thanks, Siddharth. Cheers.
Thank you. Thank you. So you heard Santosh talk about just the diversity of workloads and really the massive scale that you require with AI. Now I want to turn to another part of the inference market where the requirements are actually very different. So lots and lots of workloads, and as inference is moving into more products and services, we're actually seeing it segment into different workloads depending on what you're trying to do. Some of these are, let's call it, less interactive. So they're really tuned for, let's call it, maximum throughput or the lowest cost. Other of these applications require more balanced throughput, so you have to balance throughput and responsiveness. And then there's this new class of applications that actually want very, very fast results. You have extremely smart engineers, and they don't like to wait. And that is where ultra-low latency, or every millisecond, actually matters. Each one of these types of workloads requires a different type of compute. And one of the best ways to reach ultra-low latency today is disaggregated inference. So if you think about the different pieces, both prefill and decode are two different jobs. So prefill tends to need more compute. Decode tends to need more memory bandwidth. And with Instinct, we have a very balanced machine so that we deliver both great compute and great memory bandwidth. But you can actually take this a step further. If you know what workloads you're trying to run, you can actually let customers tune each of these pieces independently. And to address this market opportunity, we've been working with Cerebras. So to talk more about what we're building together, please welcome to the stage Cerebras co-founder and CEO, Andrew Feldman. Andrew, it's great to have you here. It's been an exciting few months for you. I know that for those who don't know exactly what you've been working on, can you talk a little bit about Cerebras and what problem you've been trying to solve?
Sure. Great to be here, and great to be sort of among people who love hardware. It's nice. Look, I'm thrilled to be here with you and to announce our cool new partnership. At Cerebras, we build the world's largest and fastest chip. It's a full wafer. And we package this into a system and package systems, right, into racks and then racks into clusters. And we deliver them both on-premise and via the cloud. And you've had some of our customers up here already today. On the Frontier Labs, we serve customers like OpenAI. And in the hyperscalers like AWS, in the small agentic and the coding space, leaders like Cognition. And they do this because we're blisteringly fast.
There's no question, Andrew, that you have some tremendous innovation with what you've been working on. And our teams have been collaborating really closely over the last few years to really have Helios together with the wafer scale engine for ultra-low latency inference. Can you just educate the audience a little bit? What are we trying to do, and what does that mean for customers?
Sure. I think what's happened, and you described it previously, is that sort of AI has moved from being a novelty to being useful, and then in some domains, a necessity. And when something's a necessity, people want to use it, and they want to use it quickly. And to serve this market, this segment of ultra-low latency, we sought a partnership that could extend our capabilities and our footprint, and there was no better answer than AMD. We were already an AMD customer as we use AMD CPUs to surround our systems. And we were so excited at the opportunity to build a disaggregated solution that combined AMD CPUs, the cool new Helios rack and the Cerebras wafer scale engine.
Yeah, look, the technology is pretty cool. So just talk a little bit about how it comes together.
Sure. So as Lisa described, what you have with Instinct in the Helios rack is you have the leader in performance and memory capacity. And you marry that with our wafer scale engine, which is the leader in SRAM and in memory bandwidth. And that combination allows us to deliver a solution that is unmatched in the industry.
So very, very exciting. I know that customers are excited about what we're going to do together as well. So when are we going to have it in market?
Later this year, and it will be first in the Cerebras cloud, and it will be later at a store near you.
I think the key thing is we're going to give customers a choice to really put together, what is the solution that they want. And I think we're very, very happy to be able to do this together with you. I think it's a huge step up in terms of what we can do for this ultra-low latency segment.
I think that's right. I think until recently, customers they could have high throughput, or they could have extraordinary speed. And by bringing together the Helios rack with the Cerebras wafer scale engine, we give you 5 times the throughput while continuing to deliver this extraordinary speed. It's really something amazing.
Fantastic. Well, look, Andrew, huge congratulations to what you and the Cerebras team have done. I mean, I think it's been incredible. I think you've been clear on what you were trying to accomplish, and it's really nice to see not only it come together, but us come together to offer a solution that will be very, very compelling to customers. So we can't wait to get this into customers' hands.
Soon.
Thank you.
Good to see you. Thank you so much.
Thank you, Andrew. All right, so look, I think we've shown you a lot of hardware this morning, but as we all know, hardware is only part of the story. It's actually software that turns all of this into a platform that developers can really build on. So to share the progress we're making with ROCm, please welcome AMD Senior Vice President of AI, Vamsi Bopanna, to the stage.
Thank you, Lisa. Good morning, everyone. Morning. It's great to be back to talk about software. Just a few years ago, programming AMD GPUs required deep expertise and significant engineering effort. We've come a long, long way in a remarkably short period of time.